Okay, welcome back to IGB100. Today we're going to be adding a little bit more to the SHMUP that we were working on from the previous week. This time we're going to be talking a little bit about game rules and interactions, particularly in the forms of some kind of rules that restrict the player's boundaries of movement. So what you'll notice is when you play the game now, we have the freedom of control that we set up from the controls last week. However, we can kind of go off screen a little bit, and we ideally would like to avoid this. So we need to set up some boundaries for the player to be restricted by so that they don't go off screen. So to do this, we're going to make use of a new script called Game Manager, which you should be able to find on Blackboard. Just drag that script into your scripts folder within your assets directory. And Game Manager is just going to be what's called a singleton setup of a class that has some public variables that we can gain access to wherever we are in the game world by whatever game object. So to get this working, let's make a new game object empty. We'll call this empty Game Manager, and we'll just attach this Game Manager script to it. Also open it up in Visual Studio. Now currently this script has a bit of stuff relative to it being a singleton instance. We don't need to pay too much attention to that, but I will first of all get you to put in two variables related to the boundary of this environment, and they are going to be two public floats. First one called X boundary, and we might make this something like 95, as well as another public float called Z boundary, and this will be equal to, I think, maybe 35. So the idea here is that our player wants to grab these boundary floats from Game Manager using the instance of Game Manager that exists in the game world. So the fact that we have this script on this game object means that we can access it through player if it's a singleton. So in our player script, well, what we'll first do is make a new method call to boundary. We haven't written this method yet, so down about, let's maybe put it under movement, we'll make a private void boundary. And within boundary, let's first of all make a check to X boundary conditions or checks, which means here we can say that if, as a player, if my position dot X is greater than the game manager dot instance dot X boundary. So that, in this case, we're checking the instance of Game Manager, its X boundary variable. We're comparing ourselves to it, and if we are greater than it, then let's just say that the position.x is equal to the game manager dot instance dot x boundary. So following up on this, we also want to check if we are on the other side of the screen, so we can follow this up with a else if, checking if our position dot x is less than negative game manager dot instance dot x boundary, and if it is, then let's just copy this line of code, make it equal to it again. That'll be minus game manager though. So basically, if we go over the boundary, we're going to be set to it on either side of the x-axis. Now, for the y boundary checks, all I'm going to do is copy this code. I might rename that. And instead of x, I'm going to put z in all of these instances. Cool. So save that script, and when that is all done, go back into Unity, Make sure your player script is not giving you red errors down here in the console. And when you play the game, your player should be stopping on the boundaries of the screen. Now this is assuming you have not changed the altitude of the camera. I believe we by default set the main camera to be 75, so if you have changed that, this may not look the same, but you won't be able to go past whatever the values are that we set, which I think were 95 and 35 here. So, basic boundary game rules. Okay, so one other variable that our game manager is going to need is related to the enemies. Now the enemy is going to need to know where the player is. Typically you would have some kind of real-time acquisition of the player, but our game is a little bit more simplistic. What we want is when enemies spawn in the game, they automatically understand where the player is. And we can actually store that information within our new Game Manager class. So within Game Manager, within its actual script, I just want you to make a new reference to a public game object player. Now within Unity, make sure you save that script. On your Game Manager, you should see a new player game object open up. I want you to drag the player object from the hierarchy into that instance. Cool. Alright, let's set up the player. To do this, our enemy is first of all just going to be a cube. So drag a new cube into the scene. Let's make it called enemy. Let's put it back on the point of origin. So let's say 0, 0, 0, and maybe put it at 25 on the Z, just so it's a little bit further up. So that's going to be our enemy. So now that you have your enemy model positioned correctly, we're going to make some adjustments to this so it looks a little bit more threatening than just the white cube that it currently is. The first thing we're going to do is attach a proper model file to this. So if you go to Models, Free Droid, you'll see this model that we've set up for you already called Bake. Let's attach that to our enemy, making it a child object, and we'll just rename that to something a little bit more sensible. It's currently facing the wrong way, so if you click on enemy, the parent object, let's rotate that 180 degrees. That's looking a little bit better. Now, let's make this a trigger, first of all, and also attach a component physics rigid body to our enemy. Now something that may be a little bit out of whack is our collider. As you can see, your collider may be hidden within the object there. So what I want you to do is just make this 10 on the X, Y, and Z axes, just to rescale our box collider a little bit bigger, and selecting the model file, move it back on the Z axis, maybe to about -3.5. So just push it back a little tiny bit so that it's within the box collider. So basically we're just rescaling the box collider and repositioning the model. Also, as a final note, untick gravity. We definitely don't want these ships falling down into the nether. So when you've done that, we're going to need to tag this enemy. So this enemy is a game object that needs some kind of reference for communication within the game world. It needs to have some kind of classification. So what we're going to do is add a tag specifically to this enemy. Conveniently, there is the enemy tag already set up for you. If it isn't, you can add tag, make that tag a enemy or whatever you do want to call this. This is going to be a generic enemy tag applied to all enemies. So when your enemy is tagged as an enemy, we're going to need to attach a new script to this. So within your scripts directory, within the assets folder, make a new script, C# script, call it enemy, and attach it to your enemy object. open that up in Visual Studio. Whoops, not sure what's going on there. Now, our enemy is going to have a little bit of basic functionality, the first being the ability to move towards you. So let's make a public float move speed and equal to something like 15. Our enemy is going to have some health, so let's make a new public float called health, and it can be 100. Again, public floats can be adjusted within Unity when you attach it to a game object, so these values doesn't really matter what they are at this point. Now, the enemy is also going to be able to do damage to you, so let's go ahead and make a public float called damage, and we'll set it to something like 25. So if you take 4 hits, if you have 100 health, you'll be dead. We'll also have a damage timer. So let's make a new private float called damage rate, and we will set this to something pretty quick, like 0.2, as well as another private float called damage time that keeps track of the time that it's going to do damage to you. And we don't need to set that as anything. Finally, our enemy is going to explode. So we need to give this a public game object death effect. And that's just going to be an explosion effect that we'll fill in eventually that this ship is going to have. Cool. We don't need anything in start. In fact, if you wanted to, we could get rid of that. However, we do want to have a method call in update. And that's going to be a movement method call. Now movement, this is going to be a basic enemy movement where it's going to simply beeline for the player in a kamikaze-like fashion. So make a new private void called movement, and here we're going to make use of our game manager class. We are going to check, this is what you call a null reference check. We're going to see or check if the game manager dot instance dot player, that variable that we set up before, if that exists, then first of all let's transform dot look at the player. In this case, the game manager dot instance dot player dot transform dot position. I know that one's a bit long, but that is what we need there. So we're just basically going to tell our, whoops, I'm missing an A there, sorry about that. Basically going to tell our current game object, which is the enemy, to just look at the player. That's all it's going to do. If there's a player that exists, look at it. And assuming you're looking at it, if you move towards it, you'll close the distance between it. So all we want following this is transform.position is going to be plus equal to the transform.forward multiplied by the move speed multiplied by time.delta time. And that's it. This should be set up to work. If you save that script, go back into Unity, again, make sure you don't have any errors. If you have errors, it's not going to work. These aren't errors, by the way. If you press play, that enemy should attempt to chase you. That's all our enemy is going to do. So currently our enemy will chase us, but that's about all it does. We can't actually interact with it, and it can't actually do any damage to us. So let's remedy that. The first thing we're going to need to do is actually open the bullet script. So wherever your scripts exist, open the projectile script and just have it ready for when we need to adjust it in a couple of seconds. But back in the enemy script, let's write a function that is essentially going to be about taking damage. So you're going to shoot your enemy with the projectiles, And this enemy is going to be able to public void take damage. This function is going to have a parameter. That parameter will be a float, and we'll call this float damage. Now for anyone who remembers their C#, they'll know that this is a method that's potentially going to get called, and it's going to pass a parameter to it. That parameter being the amount of damage. As you would expect, when something takes damage, that damage is mitigated from its health pool. Now of course you could have armor calculations here and whatnot. We don't have any of that. It's just going to be straight damage taken away from health. We're also going to combine an if statement in here to see that if our health is less than or equal to 0, then let's just kill this ship. So we can first of all say that we're going to destroy this .game object, essentially despawn us from the world, as well as instantiate a death effect. We're going to put this at our transform.position and transform.rotation. So our enemy can take damage, but the problem right now is that our projectile can't actually deal any damage. So what we need to do is in our projectile class make a new method call that's going to be a trigger event. This trigger event is specifically going to be called on trigger enter. And let's just get rid of some of this stuff. Void on trigger enter collider other. That is the parameter that we're going to use here for our object interaction. And this object interaction is going to be in the form of an if statement that asks the other object, if it's transform dot tag. Remember when we tagged the enemy object to be enemy? This is how we're communicating with it. We're going to ask if that tag is equal to enemy. Then let's do a couple of things. The first of all being, let's do some damage to the enemy. Now we haven't actually set that up to work yet because we don't have a damage variable. So what we can do is set up some damage. Public float damage is, just for the sake of making this as straightforward as possible, let's just do a flat 100 damage. So 1 hit kills. Back in our void on trigger enter, let's then say that we want the other object, so other. We're going to specifically talk to a component on this enemy. And that component is a script that is conveniently called enemy. So we're going to talk to the script on that enemy. And what we can do when we talk to a script on the enemy is if it's public, which it is, we can then ask the enemy to essentially take damage. Now we pass that parameter in. That parameter is going to be damage. That's what we've called this variable up here. We're going to tell take damage to take 100 damage. And then we're going to destroy the projectile. So let's walk through the interaction here again. Enemies have the capacity to take damage. When they take damage, if their health is less than or equal to 0, they'll blow up, they'll spawn a death effect. Great. Projectiles have the capacity to do damage. In a trigger event called onTriggerEnter, if they collide with another object that's tagged as enemy, which our enemy is, it'll tell that enemy to take damage, and then it'll destroy the projectile. It sounds complex here, but once you actually see it work in game, it's not that complex. So back inside Unity, if your scripts are all good, you're not getting any errors, we're only missing one thing, and that thing is the death effect of our enemy. So if you go to the effects folder, we should have an explosion effect ready to go. If you drag that into the death effect, it should accept it. And assuming your object interactions are all set up correctly, which if you would have followed this video, it should be. If you press play now, you fire one shot at the enemy, it blows up. Great, that's exactly what we want. If at this point you aren't getting that result, please ask your tutors, because you can't really progress onwards until that is working correctly. So once that's working correctly, there's only one more thing that we're missing from this interaction, necessary to make this a kind of a game. The player can do damage to the enemies and shoot them down, but the enemies can't do damage to the player. Now all these enemies are going to do is run into the player to do damage. They're not shooting projectiles at this point. They could. You could maybe do that yourself. However, the enemies have no capacity to do damage to the player. And that's because if you open up the player class, the player has no capacity to actually take damage. The player doesn't even have hit points. So let's fix that. Let's make a public float health, and we'll maybe make that equal to, let's say, 100. Now, at the bottom of player, we're going to need a method call. And that method call is going to be very similar to the one that we wrote here. In fact, I'm just going to borrow that. Let's take that and let's put that into player. Now it'll complain because there's no death effect. So we will need to make, similar to the enemy, at the top of this, a new public game object death effect that we're going to drag that same explosion in as we did with the enemy. We'll do that in a sec. So, the player has now the capacity to take damage and die. It can disappear. But the enemy does not have the capacity to do damage. So, going back into the enemy class, we're going to need to set up another trigger event. And that trigger event is going to be a void on trigger stay. Let's just get rid of those aspects. Now, before we progress, we also need to set up another tag. So go back into Unity, and if you have not already attached a tag onto player, put the pre-set up player tag on it. So the player is tagged as player. Go back into the enemy script. Now we can check if other.transform.tag, if that is equal to player, then we can do something about that. But before we do that, we want to make the player only take damage at a particular rate. So if you remember correctly, at the top of the script we had some variables talking about the rate of damage. We don't want the player to take damage every frame. Not only is that imbalanced, if you have a low frame rate computer you're going to take less damage, it's not a really good mechanic. So here let's attach something to do with time. Specifically, if the time.time is greater than the damage time, then do something specifically about that. So this whole statement becomes our condition. If it's a player and it's time to do damage, then first of all, let's say the other object.transform.getComponent. In this case, that component will be the player. We want the player to, let's go back to our player class, do this, take damage. If I'm an enemy and I run in to something called player and it's time to do damage, then tell it to take damage. What is that damage? Damage. And finally, at the end of this, let's increase the damage timer so that we aren't doing damage every frame. And that will simply be the time.time plus the damage rate. Now, there are a few ways you can do timers here, but this is generally the most straightforward and works about the same. So saving that, if you go back into your game now, before you do anything, again, make sure your player is tagged as player, but more importantly, make sure that death effect is full. And I'm just going to drag the same effect that the enemy uses when they explode. If you press play now, just wait a few seconds, yeah, there we go, we've died. So now the enemies can do damage to us. And we can of course do damage to them. So now that everything is working correctly, if you have a bit of spare time, I would highly suggest going through and maybe tweaking some of the variables related to the damage time, the amount of damage, the hit points that the various ships have, maybe the movement speed that the enemy has. Next week we're simply just going to be doing a little bit with enemy spawners, specifically a simple function controlling how they spawn, how quickly they are, how many enemies appear on screen. But for the moment you may just want to balance the simple interactions that a single enemy has with the player. In this case, you're pretty much killing it straight away. You may want to change that, however.